The Kuiper belt is one of the most mysterious and remote regions of our solar system, and yet it has fascinated astronomers for centuries. This vast, icy expanse, which stretches far beyond the orbit of Neptune, is home to countless comets, asteroids, and even dwarf planets, but it wasn't until relatively recently that scientists began to unlock its hidden secrets. Though it was theorized by astronomers in the early 1950s, the existence of the Kuiper belt wasn't confirmed until 1992, and even now, much of its true nature remains a mystery. As technology advances, however, new discoveries continue to be made, some of which are so sensational that they have the potential to completely alter our understanding of the outer reaches of our solar system. For a long time, the Kuiper belt was considered an empty, frozen wasteland, a place where icy chunks of debris floated aimlessly in the distant reaches of our solar system. But recent findings, particularly from the James Webb Space Telescope, are revealing that this region is much more dynamic and complex than previously thought. Some of the most recent discoveries suggest that not only is there a possibility of a large, unknown planet hiding out there, but also that certain celestial bodies within the Kuiper belt might actually radiate heat, potentially even harboring life in the most unexpected of places. Could this far-flung region, once thought to be a barren void, actually hold the key to understanding the formation of our solar system, and perhaps even the origins of life itself? The answers may be more profound than we ever imagined. The story of the Kuiper belt begins with the theorists who first speculated about its existence. In 1950, Dutch astronomer Jan Hendrik Oort proposed the idea of a vast, spherical cloud of icy bodies located far beyond the orbit of Pluto. This cloud, which came to be known as Oort's cloud, was thought to be a reservoir of comets, many of which had highly elliptical orbits that took them far out into the solar system. Oort's theory was revolutionary because it offered an explanation for the origins of long-period comets, which travel through the solar system on highly erratic and unpredictable paths. These comets, according to Oort, were the remnants of an ancient population of icy bodies that had been ejected from the inner solar system by the gravitational influence of the giant planets, and they now lived in a sort of cosmic freezer, waiting to be nudged back toward the sun by the gravity of passing stars or interstellar gas clouds. While Oort's model helped to explain the behavior of long-period comets, it didn't account for short-period comets, those that have more predictable orbits and make regular appearances in our skies. This puzzle remained unsolved until 1951, when astronomer Gerard Kuiper put forward a new theory. Kuiper proposed that, in addition to Oort's cloud, there must be a much closer region of icy objects just beyond the orbit of Neptune, objects that could explain the existence of short-period comets. He suggested that this area would form a flat, ring-like structure, and that it could be the source of many of the comets that pass through the inner solar system on relatively regular paths. Kuiper's hypothesis was groundbreaking, but there was one major problem. At the time, no telescope was powerful enough to detect objects at such vast distances, and so his theory remained just that, a theory. Despite the lack of observational evidence, Kuiper's idea remained popular among astronomers, and the search for this mysterious belt of icy debris became a major focus of space exploration. But it wasn't until the early 1990s that scientists finally had the technology to confirm Kuiper's predictions. In 1992, a team of astronomers led by David Jewett and Jane Liu, using the Mauna Kea Observatory in Hawaii, discovered the first confirmed object in the Kuiper belt. The object, 15760 Albion, was a faint point of light located just beyond Neptune's orbit, confirming that Kuiper's theory was indeed correct. This discovery marked the beginning of a new era in astronomy, as researchers began to focus more intently on the Kuiper belt, trying to understand the nature of this distant, unexplored region. Today, we know that the Kuiper belt is a vast, ring-shaped region of space that extends from about 30 to 50 astronomical units, AU, from the Sun, with 1 astronomical unit being the average distance between the Earth and the Sun, about 93 million miles. The Kuiper belt is, in essence, a much larger and more massive version of the asteroid belt that lies between Mars and Jupiter. The objects in the Kuiper belt are primarily composed of ice and rock, and many of them are thought to be remnants from the early solar system, leftovers from the formation of the planets. Some of the most notable objects in the Kuiper belt include dwarf planets such as Pluto, Haumea, and Makemake, as well as thousands of smaller icy bodies. These objects vary widely in size, with some measuring just a few kilometers across, while others are as large as small planets. Despite the vastness of the Kuiper belt, however, most of the objects in this region are small and faint, making them difficult to detect even with powerful telescopes like Hubble. In fact, it wasn't until 2019 that astronomers were able to detect an object in the Kuiper belt that was less than 10 kilometers in diameter, providing further evidence that smaller bodies exist in the region. However, even with these advancements, scientists still have little idea of how many objects truly populate the Kuiper belt. Estimates suggest that there could be more than 70,000 objects with diameters larger than 100 kilometers, but the true extent of the Kuiper belt remains largely unknown. What has been especially intriguing to astronomers, however, is the possibility of undiscovered planets or other large bodies within the Kuiper belt. For years, the search for a ninth planet in the outer reaches of the solar system has captivated scientists, particularly after the discovery of several unusual orbits in the Kuiper belt. In 2015, astronomer Mike Brown and his colleagues at the California Institute of Technology noticed that a number of objects in the outer Kuiper belt, dwarf planets like Sedna, seemed to be following highly elliptical orbits that were all aligned in the same direction. This unusual pattern suggested that there might be some external influence, possibly a large, unseen planet, that was causing these objects to behave in this way. After further study, Brown and his team concluded that the most likely explanation for these orbital anomalies was the presence of a massive, undiscovered planet, which they dubbed Planet 9. According to their model, Planet 9 would have a mass about 10 times that of Earth and a diameter slightly smaller than Neptune. It would orbit the Sun at a distance between 400 and 1500 astronomical units, much farther out than Neptune, which is about $30 from the Sun, and it would take approximately 15,000 years to complete one orbit. The hypothesis of Planet 9 has generated significant interest in the astronomical community, and Brown himself has stated that he is 90% confident that such a planet exists. Despite the growing evidence for Planet 9, the planet has yet to be directly observed. This is partly because it is so far away, and partly because it is likely to be very faint, emitting little or no visible light. Model calculations suggest that Planet 9's intrinsic luminosity could be as low as 0.006, which is much lower than Neptune's value of 0.01. As a result, the planet would likely be invisible to most telescopes, even the most powerful ones. Moreover, it is possible that Planet 9 is currently located at the farthest reaches of its orbit, making it even more difficult to detect. While Planet 9 remains a hypothetical object, the possibility of its existence has profound implications for our understanding of the solar system. If it does exist, Planet 9 would be a huge object, much larger than Pluto, and it would add a ninth planet to our solar system, reintroducing the idea that Pluto could once again be considered a true planet. But there's more to this discovery than just the potential for another planet. Some scientists believe that the gravitational influence of Planet 9 could also help explain some of the more unusual characteristics of objects in the Kuiper belt, such as their strange orbits and the alignment of their trajectories. In addition to the search for Planet 9, astronomers are also exploring the possibility that life could exist in the far reaches of the solar system. While it might seem far-fetched to think that life could survive in such an inhospitable environment, new research is suggesting that the Kuiper belt may not be as lifeless as we once thought. In fact, recent data from the James Webb Space Telescope has uncovered evidence of warm, active cores on two Kuiper belt objects, Eris and Makemake, that could potentially harbor liquid water beneath their icy surfaces. These discoveries have led scientists to speculate that, just as icy moons like Europa have subglacial oceans, some of the frozen dwarf planets in the Kuiper belt may also have liquid water beneath their icy exteriors. The presence of methane on these objects also suggests that there may be processes occurring within their interiors that could support the emergence of life. These findings are still in the early stages, and much more research is needed to fully understand the potential for life in the Kuiper belt. However, the idea that life could exist in the most unlikely of places is a tantalizing possibility that has captured the imagination of astronomers around the world. As our technology improves and our understanding of the Kuiper belt deepens, it seems clear that we are only scratching the surface of what this mysterious region has to offer. From the potential discovery of Planet 9 to the possibility of hidden oceans and even life, the Kuiper Belt is proving to be a far more dynamic and exciting part of our solar system than anyone ever expected. The future of exploration in this distant frontier is filled with promise, and it's likely that many more surprises await as we continue to push the boundaries of our knowledge and explore the farthest reaches of the solar system. The Kuiper Belt is no longer just a dark, icy expanse, it is a place where new worlds, new discoveries, and perhaps even new forms of life may one day be found. The journey is just beginning, and the answers to some of the biggest questions about our solar system may be hiding just beyond our reach.